Okay, today we are going over 5.5. Let's start off with our bell ringers. Number one, what is the one theorem we use to prove triangles are congruent? So far, we've only learned one theorem, and that is our side angle side theorem. So, side angle side theorem. Number two, what does included mean? Well, included just means it's somewhere in the middle. In the middle. Remember, our side angle side has the angle included. In an included angle, that angle is in the middle of our two sides. And then number three, draw a right triangle below it and label A, B, C. So let me do that right now. So we'll say right triangle. And we can always tell it's a right triangle by putting our box here in this corner, saying this is going to be right. So we'll say this is A, B, and C. The next one, the longest side of a right triangle, semicolon, the opposite side of the right triangle. So what is the name of the longest side of the right triangle, which is also the opposite of the right angle? And that is called our hypotenuse. So the hypotenuse is here. So this is our right angle here. Opposite of it, this AC is our hypotenuse in this case. So I'm going to just say AC for our example is our hypotenuse. The legs are the sides that make up the right angle in the right triangle, the sides adjacent to the leg. So the other two sides are the legs. So here AB and ABC are the legs of this particular right triangle. So let's try it out. Let's try some of this out. Here we have 16, 34, and 30. Name the legs and the hypotenuse. Here's one thing that you need to know about all right triangles. The hypotenuse is always going to be the longest length. So here I see 34. That is going to be my leg. Opposite of that is going to be my right angle. So this is going to be my right angle right here. And also you can tell it's going to be a right angle because it looks just like the corner of a rectangle or a square. Here this is already given you my the right angle, so the hypotenuse is C and the legs are A and B. So A and B are my legs and C is the hypotenuse. Here my hypotenuse is MN and my legs are LM and LN. So that brings us to the next theorem that we will learn is our hypotenuse leg. Our hypotenuse leg congruence theorem, or HL, hypotenuse leg, if the hypotenuse and the leg of a one right triangle are congruent to the hypotenuse leg of another separate right triangle, then the triangles are congruent. And in order to prove this, we first have to prove it's a right triangle, and then second, we have to prove that the hypotenuse, or the longest side, and one of the legs are congruent. So if I drew, let me just say I have a right triangle here and a right triangle here. And here's my right angle, and here's my right angle. And I'll call this one A, B, C, and this one X, Y, Z, and I prove that this hypotenuse is congruent to that and any one of the legs. So if, let's say, here is congruent to this one, then I can guarantee, because these two are both right triangles and they have the hypotenuse and the leg congruent, then we can say that triangle, I'll say ABC, and is congruent to triangle. We have to be careful now. A matches up with Z in this case. A matches with so Z. Y matches up with B, and X matches up with C. So ABC is congruent to X, Y, Z, Y, X. Next congruence theorem that we are going to learn is our side, side, side. Congruence theorem, or SSS. If basically it says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So it's just basically saying, oh, so let me draw an example here. Let's draw an example like this, and an example like that, and I'm saying these we'll call this ABC again, ABC, and X, Y, Z, and I say, oh, all the sides on one triangle matches the other side. They correspond to the other. So if all the sides are congruent to each other, then these two triangles must be congruent. So then, write this properly. Triangle ABC is congruent. We have to be careful how we match up our angles. A matches up with X. B matches up with actually Z in this case. Z. And C matches up with Y. So ABC is congruent to triangle XZY. Let's move down here a little bit. Let's try it out. Can you tell the triangles are congruent by using hypotenuse, leg, side, 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 angle, side, or not possible? Okay, so let's give this a try. Let's look at number one. We have ADC and BEF. I see three sides that are congruent, and I'm going to say yes because of side, side, side. Here I see one side, the side AC, is congruent to the side BE. Another side, AD, is congruent to side BF. And then another side, CD, is congruent to EF. Let's check out number two. Ooh, we have some right angles. And I see, oh, I don't see the hypotenuse being congruent, but I see the two sides. So this, we can't use hypotenuse, leg, but we have another alternative. We have a side, angle, side that we can use. So number two, this is a side, angle, side, because we have a side here. GI is congruent to KL. The angle in this case is our right angle. So angle G is congruent to angle L. And our last side, GH, is congruent to JL. Okay, let's move on to number three. Number three here, I have a angle and a side, side. But we don't have an angle, side, side. We only have hypotenuse, leg, side, 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 angle, side. So this one is actually a big old no. We can't use anything for that one. Let's move on to number 4. Ooh, I have 2 sides, so I can use either side, angle, side. Let's see here. Is the angle in between the 2 sides? That is a yes, because I have the sides. So here, I'm going to say yes, side, angle, side. So here's a side. ST is congruent to, let's say, VX. An angle, we know angle S is congruent to angle V. And then lastly, SU is congruent to VW. Okay, moving on to number 5. We have a side. Let's see here. I don't see any other tick marks per se. I know with reflexive, I can do the one singular one, but I don't see any other sides or any angles. So no, I either need one more angle or one more side, but we don't have that. So no, I can't prove that. Let's go to number 6. All 3 of those angles are congruent. However, those are angles. We need a side. We don't have any sides. We don't have at all. We don't have a hypotenuse leg. We don't have a side, side angle, side. So no, I don't see anything that will allow us. Even though those are 3 angles, it's not enough. That's not one of our theorems. Okay, let's look at number 7. Number 7, we're given 2 sides, but I can see here using vertical angles. Remember, these are vertical angles. They're in the middle on the opposite side of those 2 lines are congruent. So I see 2 sides and an angle in between them. So this is a yes. I can use side, angle, side with this. Our side here, IK, is congruent to KM. Angle IKJ is congruent to angle LKM. And then our last side, JK, is congruent to KL. All right, let's see if we can find any angles here that are congruent. Oh, I see 2. If you notice, I'm going to highlight here. These 2 triangles on the side, on the ends, those are congruent because look, all 3 sides. I can match up 3 sides to each other. So this is a yes, and I can say side, side, side. And I'm just going to be focusing on the 3 sides there at the ends using that. One side being ON is congruent to RN. Another side OP is congruent to QR. And another side PN is congruent to QN. Okay, going on to number 9. I got 2 sides and an angle, but they're not in between the 2. But however, using reflexive property, I can say that that middle side is congruent to itself. So this is actually an yes. This angle here and this right there is not in between the 2, so I can't use side, angle, side, but I can use side, side, side here. So a side SU is congruent to UV. Another side ST is congruent to a TV. And another side UT is congruent to itself using reflexive property. Number 10, oh yes, I see 3 sides congruent to each other. This is a yes. This is also a side, side, side. Since all the sides are pretty much the same length, you can pick any sides and it'll work. You just pick any sides, match them to each other. All of these 2, if you don't notice, they are equilateral triangles. Okay, here, number 11. Here, I see a side, and I know I can use reflexive, but I don't have any angles or a third side, so this is going to be big. Oh, no. And then finally, number 12. Yes, I can definitely. I see 3 sides, and we can do a side, 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 and you can name those sides accordingly. And that is all we have for today.